Welcome to this Alaska Land Mobile Radio training presentation, ALMR Basic Academy. Please note that this training presentation was adapted from an in-person class given in October 2024. When we define the ALMR system, the entire system consists of various pieces of equipment that all connect to the ALMR system core. This equipment can include the different master sites and radio frequency sites. These are the sites that connect to the system and your radio affiliates to when using ALMR. It also consists of system servers, but also equipment that connects, such as dispatch consoles, the various centers throughout the system, logging recorders, key management facilities, amplifiers, and other similar equipment. All of these different components that may be owned and operated separately are connected to the ALMR system and are considered part of the ALMR infrastructure. Technically and administratively, the ALMR system is divided into 4 zones. The main 2 zones consist of Zone 1, which is areas south of the Denali Highway that includes southeast Alaska. Zone 2 includes all areas north of the Denali Highway in the interior region. Zone 3 is reserved for potential use in southeast Alaska, and Zone 4 is the municipality of Anchorage, called the AWARN system, or Anchorage Wide Area Radio Network, which is operated by the municipality but is part of the ALMR system core. The ALMR system consists of 86 different radio frequency, or RF sites. These sites are what your different subscriber units or radios affiliate with when you are communicating on the ALMR system. The tower sites consist of various pieces of equipment that are maintained by the ALMR group as well as the state of Alaska. Some tower sites are owned by their individual entities, generally by the Department of Defense for sites that are on installations. Tower sites can include the physical infrastructure, such as towers, antennas, generators and power systems, buildings, and other systems. For the ALMR system, the site equipment itself takes the radio frequency inputs and outputs and connects them to the wider network. The wider network of ALMR is transited over SATS, for the State of Alaska Telecommunications System. The SATS system provides the transit for all ALMR data and enables the wide area connectivity. SATS is primarily a microwave radio network. Microwave is a broadcast technology that allows us to link various sites together in a point-to-point basis. In other words, one ALMR tower on the SATS system points to another tower using microwave dishes, which are generally the circular white dishes that you may see mounted on towers. These 2 dishes are exactly aligned and are able to transfer a high amount of data between the 2 sites. Most ALMR sites have at least 2 connections. That way, if one connection fails, the other can take over seamlessly, and the ALMR system is able to be robust and reliable in this way. The microwave network is maintained by the Department of Public Safety, Alaska Public Safety Communications Services, which is based in Anchorage and has staff in several other areas of the state. The SATS team, as well as the ALMR team, work together on a daily basis to ensure the 2 systems are working properly and providing the maximum amount of reliability. The SATS system has 144 sites. 50 of those sites are accessible only by helicopter. It includes 109 towers and 78 generators. The SATS team is responsible for maintenance of all of the associated equipment for ALMR that was previously mentioned, such as generators, power systems, buildings, tower maintenance, and others, while the ALMR team focuses on the antennas and the site equipment, as well as the site administration and system of the entire ALMR network. The ALMR system uses a technology or set of standards known as Project 25. APCO Project 25 standards are for public safety wireless networks. They focus specifically on security, reliability, and interoperability. The graphic on the screen shows some of the different components of the Project 25 standard. We utilize this standard because of the focus on public safety and reliability, and because the standard allows for the use of various vendors and different pieces of equipment and is not proprietary to one brand or manufacturer. Project 25 standards really became into play to make more efficient use of the radio spectrum. As more and more wireless technologies are putting pressure on the use of the spectrum, the available radio frequency spectrum that are available for public safety continues to shrink. The trunking system is able to use the same set of frequencies much more efficiently and through a wider geographic area than older conventional systems. In addition, the Project 25 standard is a digital technology. Instead of your voice being transmitted in an analog format, it's converted to packets similar to how a voice phone or a Teams call would be, and that allows the data to be compressed and to use the data networks such as SATs to transfer data back and forth into a wider area. This provides for a higher level of features and technologies that may be available to us, such as tracking the radio ID that keys up, potentially in the future services such as location on push-to-talk, remote management and remote security, as well as many other features that may or may not be available in the ALMR system that are part of Project 25 and may be looked at for future expansion. The main advantage of Project 25 is that it is an interoperable standard, but also the multi-vendor standard, so as to ensure that we are not locked in, nor any of our agencies that are members of ALMR, locked into a particular vendor when it comes to radios or other equipment. There are some disadvantages to Project 25 when compared to conventional systems. The main one for agencies is the higher initial equipment cost for radios and other subscriber units. However, there is also a higher level of infrastructure required, such as the 86 tower sites that the ALMR system runs on. ALMR is not as conducive to short-range communication needs, and when we talk about this, this is more on-scene communication that you might see at a large motor vehicle collision, structure fire, mass casualty, or other incident. Because of the technology and the way the wide area trunking and the different sites have different capacities, it may still be advantageous to use conventional radio in these instances, which are part of our interoperability plan to allow both of those tools to be available to system users. The ALMR governance structure consists of several different organizations and bodies. The Executive Council consists of representatives from the Department of Public Safety, Federal Department of Defense, Federal Non-Department of Defense, and a municipality representative. The Executive Council is responsible for high-level approvals of policy and procedure, strategic direction, and other organizational factors that affect ALMR. The ALMR User Council is the body that is involved in more of the daily operations of the system and represents different regions and users throughout the user base. Each user organization has an elected representative on the ALMR User Council. These meetings are held monthly and typically goes into detail as far as ALMR system issues, maintenance and operation, statistics, downtime, and other factors. Policy and procedure that affects users for the ALMR system is centered through the User Council process. All members are invited to attend the ALMR User Council and can submit information or questions through their ALMR User Council representative. Contact the ALMR Operations Management Office for contact information on the User Council meeting, which takes place both virtually and in person in Anchorage. Past minutes, packets, and other items for the User Council and Executive Council are available on the ALMR website for reference. The System Management Office consists of the daily technical operation of the system. This office is contracted through an organization called Bering Straits Information Technology, based out of Anchorage. The System Management Office consists of ALMR technicians, the ALMR Help Desk, and the System Manager. The System Management Office is available at all times for any technical issues or needs from ALMR users. The Operations Management Office is a separate entity that is primarily responsible for policy, procedure, governance, and compliance. This is a contracted office, which is contracted through a firm called Wassman and Associates based in Juneau. The Operations Management Office consists of the Operations Manager, Documentation Specialist, and Training Specialist. These offices are separate to ensure that the wishes of the user community are fairly represented throughout the management of the ALMR system. This is why these contract positions are outside of any particular agency or organization that may be able to affect policy adversely towards their needs rather than the needs of the system and user base as a whole. Finally, as part of the organization, the Department of Public Safety, Alaska Public Safety Communications Services, as we previously discussed, maintains the State of Alaska Telecommunications System, or SATS. This responsibility ensures that the SATS system, run by APSCS and ALMR, work together, and those personnel groups work daily to ensure the reliability and operation of that system. ALMR as a technology provides coverage through the highway corridor and some population centers of the state. It is not available yet as a completely statewide system. ALMR uses VHF technology, or very high frequency radio technology. VHF is suitable for longer range and broader outdoor propagation, which means each ALMR RF site is able to broadcast signal further and provide more coverage in general. There is another radio technology called UHF, or ultra-high frequency, which may be used by some public safety agencies, including within the municipality of Anchorage, that is more conducive to dense urban environments. That is because the UHF frequency is able to penetrate buildings better than VHF. Communications require a line of sight to the tower, which means your radio must be able to see the ALMR tower that it's affiliated with in order to effectively transmit. This is why entering some buildings, especially those that are fairly well built, examples could be things like schools and hospitals, may diminish or block ALMR coverage completely. This is due to the VHF technology that's being used and the blocked line of sight to the tower. VHF is still the best technology for use to provide that high level of coverage. However, it does have certain areas that it's not able to penetrate, like the building example. There are technologies that are being used and starting to be deployed that may be able to deal with some of these coverage issues. One of these, for example, is the installation of bidirectional amplifiers. These amplifiers are installed in buildings such as schools or hospitals that may be able to repeat the ALMR coverage to an antenna that's located outside the building. There is a vast technical infrastructure that's required for these BDAs, as well as annual maintenance, and the cost for the system is generally prohibitive for most business owners. Fire code requires the installation of some of these. However, the actual rollout and implementation varies depending on the area of the state that you're in and the particular requirements of the jurisdiction. Other future technologies are being investigated that may be able to use broadband and other LTE technologies to connect to the ALMR system. At this time, an approval process is underway in order to attempt to connect some of those technologies to the system. However, because part of ALMR is owned by the Department of Defense, it is required that federal DoD requirements for security and cybersecurity be met. This lengthy process means that various systems cannot simply be connected. They must go through an extensive approval process before they can be turned on to the ALMR system. The ALMR system was originally engineered and designed with 95% mobile coverage within the projected service area, which includes areas in the southeast and some communities, as well as the road system. Please note that this engineering consists of mobile coverage, which is the use of mobile radios that have higher power and external antennas, as opposed to portable radios. If you are not able to get portable coverage in specific areas, attempt to use your mobile radio for increased power, as this generally will allow for communication with the ALMR system in most areas. Keep in mind that the density of towers and technologies that would be required to provide full portable coverage was deemed cost prohibitive when the system was engineered. Again, this discussion may go into some of the previous technologies that are starting to become available in order to supplement ALMR coverage, but be aware that the system itself is designed for mobile coverage, and therefore portable coverage may not be predictable or guaranteed in some areas, such as inside buildings. When discussing ALMR coverage, it is important to note that the digital transmissions that are used for ALMR may differ from older radio systems that you may be familiar with. When entering fringe areas or areas of lower coverage, conventional radio may typically become noisier, having more static, but you still may be able to pick out most of the words that are being said. Digital transmissions generally are an all or none, and they may fall off very quickly once coverage is diminished. You may also have some artifacts or some digital noise in the transmission when you get into fringe areas, as that represents part of the transmission being completed, but not all of it. When there is no coverage or a radio is unable to transmit, you'll generally push the push-to-talk button and get an error, usually an error tone like a bonk or some other indication that the radio does not go through. Transmissions can fail due to a number of different causes, the most common of which is the inability to reach the tower. However, there are a few other indications that you may wish to check if you are having consistent problems with failed transmissions. Please be aware that some radios are programmed to automatically retry transmissions after a few seconds. You may wish to check with your agency on how your radios are programmed and what that timeout delay is. When receiving a failed transmission error, it is common to assume that the ALMR system is busy and unable to accept your transmission. This occurs if the radio frequency site that you are affiliated with is at capacity, and it's referred to as a system busy. System busies are extremely rare, generally occurring less than 1,000 in a month. For example, in October of 2024, there were just over 2 million calls and about 800 busies. In June 2024, there were 856 busies out of 1.5 million calls for the month. As a percentage, a very small number. When each site is set up, it has a certain number of channels associated with it. For example, if we talk about a site that's a 5-channel site, one channel is used for system operations, which leaves 4 channels available for radios to use. If 4 radios are using different channels on the site and a 5th radio keys up, that's a site busy. The transition to TDMA technology will assist in the site busies and increase capacity for everyone in the system. The TDMA transition, which is targeted to complete at the end of 2026, is a transition to a technology known as time division multi-access, which refers to how the radio frequency spectrum is used to transmit information. Essentially, what occurs is the site channels available at any particular RF site double. So in our previous example, those 4 channels then become 8 channels. The TDMA transition requires all radios to be compatible and enabled with TDMA technology, as well as all site equipment to be upgraded. This upgrade process is currently completing. There is further information on TDMA-compatible radios and the TDMA transition available on the alaskalandmobileradio.org website or by contacting the Operations Management Office. Keep in mind if you are seeing site busy indications, some radios do have radio programming that has a site lock feature. This could enable one of the keys on your radio to lock to a particular site. As you travel away from that site, the radio is still locked to only that RF site, as opposed to whatever ALMR site is closest, which is the normal operation. If you have a site lock, you may get those busy signals even when you are in an area of known good coverage. Please note that the physical condition of your radio may also affect coverage. Items such as antennas that are worn or need replacement will certainly impact radio coverage. In addition, loose cables, frayed cabling, accessories such as remote speaker microphones that aren't worked properly may all contribute to some sort of signal degradation or signal block. Make sure that your radio is in good physical shape and the preventative maintenance on the radio is performed per the manufacturer's schedule, which is typically each year. Additionally, some radio programming issues can cause failed transmissions. Ensure preferred sites are not programmed into your radio. In addition, if a radio does not have the correct radio ID or has a duplicate radio ID, this can result in unpredictable behavior. If you are not able to transmit at any time, make sure the system information and radio ID or ALMR ID in your code plug is correct, as the system may not be recognizing it as a valid radio. One of the key tenets of the ALMR system is interoperability. This allows us to talk to any agency that we may need to talk to during times of disaster or other public safety needs that require communication among not only first responders, but also other agencies that may be involved in an incident, such as emergency management, Department of Transportation, Public Works, or others. Interoperability has several definitions, but essentially, the ALMR system embodies interoperability by ensuring that every user of the system is able to communicate with others via a set of interoperable talk groups and channels. These interoperable channels are common talk groups and zones that are set up in every radio that is on the ALMR system. Please note that the old version of these zones before 2019 were mapped to the Alaska State Trooper detachments, and they were called DHAL, DIC2, IC3, etc. The letter in front of those may be A through E. This is the old version of interoperability zones. If these are still in your radio, contact your agency to have them reprogrammed immediately. To simplify the interoperable groups, we now use 3 geographic zones: Southeast, Central, and North. Each of these geographic areas has a separate lineup which shows the different interoperable zones that are available for agencies in that area. Your agency must have the interoperable zone programmed in your radio for the geographic area that you represent per your ALMR membership agreement. It is recommended that if your radio has the capacity to program all 3 interoperable zones into radios, in case radios are being moved or agencies are deployed to other parts of the state. This is an example of the North Zone interoperable lineup. All 3 zones are the same, except the North is changed to Central or Southeast. The first talk group is the call talk group. This talk group is monitored by a regional dispatch center, and you can use this talk group to contact them to have additional talk groups assigned to a particular incident. For example, if you were working an incident that required 2 different talk groups for everybody to get to join and be interoperable with communications, you could request this on the call frequency and the dispatcher will assign you one of the North Command talk groups. Notice the top part of the interoperable zone, which all have the ALMR talk group designation in the receive frequency. These are trunked talk groups, as you may be familiar with. Number 7, the multi-group, is available to monitor the call through 6 talk groups in one channel. Therefore, if you will receive all of that traffic on the North multi-group, however, if you transmit on the multi-group, you will also transmit on all 7 talk groups. The bottom section of the interoperable zone are simplex channels, which are conventional. Simplex, or radio to radio, is available for on-scene operations or operations in other areas where you do not wish to use the ALMR system or you have capacity issues. These these channels in the conventional side do not require assignment by a dispatch center and can be used by any ALMR member agency as part of their membership agreement. These tactical channels and conventional channels may be useful for items such as on-scene control, like traffic control or fireground operations, or other local traffic that does not need to be routed to the wider area through the ALMR system. You can use the interoperable zones for different incidents such as natural disasters or a multi-agency incident, or communicating with other agencies that you don't typically have an agreement with or their talk groups programmed into your radio. It is encouraged to use the interoperable zones for any exercises and training that you wish to conduct, as this will allow your users to become familiar with the zones and build the muscle memory on how to access them. Contact your regional dispatch center to reserve a talk group for exercise and training operations. Please note the radio protocols for using the interoperable channel. Request usage from your radio dispatch center and be sure to practice radio discipline, as it's likely that there are a number of agencies and a high amount of traffic when using these channels for an incident. Make sure common language is used and no agency-specific codes or other acronyms are used so everyone is able to understand the traffic being sent. If possible, utilize non-trunked channels if you have local traffic, and remember that these channels do not have encryption, and be sure to transmit in the clear so everyone is able to receive the information and the radio traffic. There are several administrative responsibilities for ALMR members. The point of contact will complete the annual membership agreement, which includes certifying that an inventory has been done and your radios are accounted for. Ensure that all radios are assigned to the right person and are accounted for your agency. Any unaccounted for radios should be reported to the help desk so they can be disabled. If a radio is found, those radios can be quickly re-enabled. In addition, the policy and procedure of the ALMR system must be followed by all members. Note that the ALMR policies and procedures can be found on the ALMR website at alaskalandmobileradio.org. In addition, you will find a number of training materials, the approved equipment list, user council and executive council materials, and many other items of interest on this website. The ALMR help desk is available for contact at any time when you need assistance and is available after hours for emergencies. The Operations Management Office can be contacted for questions regarding policy and procedure, governance, the TDMA transition, or any other matters. The Operations Manager and System Manager work closely together on all issues encountered by ALMR member agencies. Please do not hesitate to reach out and use any of the resources available. You may wish to save this table, which shows the contact information for the ALMR Help Desk. Feel free to call the Help Desk or use email with any questions. Normal business hours are Monday through Friday, 7:30 to 4:30, except for state holidays. Call the number for any after-hours assistance, such as a lost or stolen radio or other type of emergency.